Good morning, guys. Sorry I'm not there today. Haven't woken up too well with my neck. But look, hopefully I'll run you through this quick little video and that will run you through the work that you need to be able to do. So look, there are three main types of questions I'm going to look at this morning. The first will be something like x squared plus 6x. The second will be x squared minus 25. And the third will be x squared minus, actually say plus 6x plus 5. Okay. Look, whenever I go through factorising binomials or factorising quadratics, there's a three-step process that I like to look at. The first thing I like to search for is to see if there is any common factor available. I will do that every single time. Once I've seen if there is a common factor or there's no common factor, I look to see if there is a difference of two squares, which we looked at yesterday. And then thirdly, if none of those two things work, or I've done those two processes, I ensure that I can't use the product and sum method, okay, or the cross method, which I don't like. But anyway, so the first one I'm going to look at, I want to factorize to start off with. There is a common factor, so we can hopefully see that there is an x that goes into both of those terms, so I factorize that out. Now look, within the brackets, I've got x plus 6. There is nothing else there that I can factorize, and we call it job done. Of course, you can expand it if you wish to make sure it's going to be x squared plus 6x. It is, and so you know that factorization is correct. That's a pretty easy one. The second one, there's no common factor apart from 1, and in this instance, 1 will not help me. So then I look for a difference of two squares. There's a difference there, and they are two squared numbers, so I can now say it's going to be x plus 5, which means the square root of x squared, the square root of 25, and I make sure that one's a plus and one's a minus. Now remember, we spoke about this yesterday. They have to be opposite signs. Otherwise, if they are the same, we have that perfect square, which means there'll be a term in the middle. The last one, okay, there's no common factor. It's not a difference of two squares. Therefore, product and sum is most likely what I'll be looking at. Now, of course, if you really want to use something like completing the square, you could, but I do not encourage it at all. Okay, your product and sum, our product number comes from 1 times the 5. Remember, we said the first number times the last number. That's where it comes from. And then the middle number, the sum, is what that one is there. So it's positive 6. So we're looking for two numbers that multiply together to give 5, which is the product, and add together to give 6, which is the sum. So I always look for the product. The product to make 5 is 5 and 1. There's no other two combinations I can give. And then I look at my sum. 5 plus 1 makes 6. So it makes both of those terms. Now, because this is a monic, okay, we can straight away just say x plus 5 brackets x plus 1. I'm allowed to do that, and that gets me the right answer. But of course, at this stage, I want to say, what if it wasn't a monic? Now, all these questions, you will have a monic, but I want to kind of address what happens if it wasn't. So the whole idea of getting these two numbers, the 5 and the 1, is because we're actually splitting that middle number up into 5x plus 1x, or whatever those two numbers might be. Now, you might say, well, why? What's the point of doing that? Well, if I do that, I can now actually split this up into two separate terms, okay, or divisions, and I can now go back to number 1 and look at whether there is a common factor. Now, in the first one, there is in fact a common factor of x. I can put it as x, which makes x plus 5 my brackets. The next one, well, there's no other number except for 1, but in this case, 1 is useful, because when I do that, what you now see is that you have a common factor, again, of this x plus 5, because it goes into both terms. So if I now finally factorize the x plus 5 out, in my second brackets, I'm left with this x and this plus 1. And if we now go back and have a look at what we got originally, x plus 5, x plus 1, you will notice that they are exactly the same. Now, of course, you don't need to go through this process because it's a monic, but if it wasn't a monic, okay, a non-monic, so you had a 2x squared or a 3x squared, you would have to go through that splitting the pair. One thing I'll address, a few boys are often concerned about here, is what happens if I didn't put it exactly as 5x and 1x? What if I alternated that around, like x squared plus 1x plus 5x plus 5? Would that make a difference? And we often get a little bit, worried about that. And what I just want to explain to you that it doesn't actually matter. If I factorize the x squared plus 1x, I get x outside of x plus 1. I now factorize the 5 out. I have x plus 1. We still have the brackets that are the same. And this time, when I factorize it out, the only real difference I'm going to have, as you can see from here, as the brackets are the other way around. And because they're being multiplied together, it doesn't actually matter. It's still the same answer. It's still all correct. So don't be too concerned about when you're splitting it, how it will be. Look, I will suggest though today's lesson that we're only doing monics anyway, so there's not going to be a major problem there because you can go straight through and do this nice little shortcut method to start with. Okay. Let's look at 2 more questions, and that will probably do us for today. So for one, we'll look at something like 3x squared minus 12, and then we'll look at something such as x squared minus 5x plus 6. Okay. So the first one, my common factor I always want to look for. In this case, there is a common factor. There's a common factor of 3. So we then get x squared minus 4 inside the brackets. Now, the issue is don't always just assume that the common factor has been completed and that's done. Because what we might see inside these brackets now, that we actually have a perfect square. So if I can now say x minus 2x plus 2, we have that extra factorization and it's completely factorized. I always look to see to make sure each of the brackets that there's nothing common between the x and the minus 2 and they're not. So we're good to go. For the next one, okay, likewise, there's no common factor. It's not a difference of 2 squares. So of course we think it's going to be a product and sum where my first number is 1 and my last number is 6, so 1 times 6 is 6, and of course the middle number is negative 5, that's my sum. Now don't get concerned with what number is negative, etc. I really don't mind by that. All I look for is this 6 and say, well, what are 2 numbers that can times together to give 6? Well, there are 2 combinations, and it's important to look at both of these combinations. What you might notice that they both multiply together to give 6, and both of them have possibilities or potentials to make negative 5. So you can be very careful because only one of those combinations will actually work. Now, if I look at the bottom one, how can I make negative 5 with 2 and 3? Well, I can make it with negative 2 and I can make it with negative 3. How can I make it with 1 and 6? Well, I can make it with negative 6 and positive 1. So, okay, one of these sets is going to have to be my solution. So, which of those make positive 6 when multiplied together? And the answer is the first one, because 2 negatives when multiplied together give a positive. This one can't be right because it would give me negative 6 as my product, and that's not correct. So now I can say x minus 2. I can then say x minus 3 as it's a monic, and then my job is done. Okay, I could go and split the pairs if I wished. I could say something like x squared minus 2x minus 3x plus 6. I could then go through and factorize and say x outside of x minus 2 minus 3 outside of x minus 2, making sure 2 negatives make the positive 6. And I've now got x minus 2 and x minus 3 outside the brackets there. And you can see they are exactly the same. There's no need to do it, but certainly it can be useful every now and then to throw yourself into that method, so it's going to help you later on. Gentlemen, again, I apologize for not being there today. Have a crack at some of the questions. Hopefully I'm well enough to come in tomorrow, and then we can look at some of the non-monics and go from there. Any problems, please feel free to email me. Otherwise, have a fantastic day, and fingers crossed I'll see you tomorrow.